So yeah, Mary Lou, you can have a science discussion. I'll talk to Gary about logistics.
Okay, and
Nathaniel,
so thinking
okay.
about logistics, I would like to say something before you disappear here.
Yes.
So today is the second day of May. Yay, May. Next week I cannot come. I will have visitors here. And then the 16th is the beginning. People will be at HamVention already on the 16th, right?
Mm-hmm.
So I'd like to cancel our meeting at that point. And then
Okay.
the next time you would see me is on the 23rd. So
That sounds good to me.
okay, so some of you, most of you should come on the 9th and talk to Gary, and I'll feed him all sorts of stuff to talk about.
That sounds great, Mary Lou. Thank you.
Okay, so
I'm gonna jump over to the.
Hey,
who all is going to this breakout room for HamVention?
Yeah, just note, in case people aren't familiar, at least on my computer, there's an icon at the bottom that says breakout room. So you should be able to hit that and then choose your room, I believe.
Yeah.
Hey,
And if you
Nathaniel,
just, yeah, there's
before
one
you
that
go,
says science room, but just if you are, actually, let me close all rooms. Close all rooms. I'm just gonna create one breakout. Delete that one. Open our room. Great. Yeah, so if you want to talk about science, you stay here. If you want to talk about HamVention logistics, you go to the breakout room. Yes.
How do you get to the breakout room? I don't see it on the bottom of the screen.
It's under more.
more.
Oh, it's under more. Of course it is.
Hey, Nathaniel, for your presentation, just get up and say, due to the vast amount of data that was generated, we have now answered all of the questions on the ionosphere. People will probably nod their head and go, "Oh, okay," and then you're done.
I don't think this crowd's gonna just nod their head. I think they're gonna throw antennas at me.
Or poke you with them, huh?
Yeah, I have a feeling this is a tough crowd. I have to give them something. Tim Duffy is the one leading this session, so you know, they want a good talk. So.
Yeah, scratch my suggestion then.
Thank you. All right, I'm gonna head over to the HamVention logistics room. Everyone else who wants to can stay here and talk about science.
So what we're going to do is to give you something to talk about. Okay, there you.
So are you going to fire up, Mary Lou?
Yes.
Yeah.
We're
Okay.
going to do this. So share screen. Slideshow. Okay, so this is the same slideshow, just more of it. It's called scientific method or something like that. And so each of the sections begins with something that has red words on it. So that's how you can find it when you finally get the whole thing. So each week it gets bigger and bigger. So this is exploratory ham science projects for today. So I want to do this in kind of a little bit of a backwards sort of scenario in a way. I'd ask people to look at the Personal Space Weather Station main control panel and look for data that was observations that were taken during the eclipse of the sun on the 4th day, 04/08/2024, which it seems you have to type that every time you want to get into this thing. I'm tired of typing this, but anyway, and to look at data. Well, there's a ton of data. I don't know. There's upwards to 80 or 90 individual observations there, and I've now looked at 24 individual people's days, and it turns out at least for me to be a lot more confusing than I thought it would. So it's what Nick said, that the ionosphere is complex, and it's more complex than I had imagined, and that's very sad. Anyway, so I thought I'd tell you first some of the things that you can do just in techniques to make your life a little easier or to make it look a little prettier. And then I want to talk about results, at least the results I've got, and see what results other people have gotten as well. All right, so this is the sort of thing I would teach college students in a lab setting, that they would get this and then they would have to do the data analysis in front of me. And the thing with college students is you can give them data that is really very good, and things will fall out and be correlated with other things. But in the real world, it doesn't happen that way. At any rate, so one of the things to do is to learn to make an Excel spreadsheet that looks really nice. And I don't know how many of you have experience with Excel spreadsheets. I think they're wonderful. My students have told me years later that this was one of the valuable things that I taught them. One of the few valuable things, evidently, that they come back and mention. Any rate, so you have an Excel spreadsheet, and you can make it look better and look more organized and be more organized by doing several things. First, make borders for the cells that have numbers in them, or the cells that have something else in them, like words. So the way you do that is you take your mouse and you highlight all the filled cells across and down, and then you stop. And then you go to Home, which is in the top menu bar. And then there's a tiny, tiny box under where it has the different font things like bold and italics and whatnot. So I look for the B for bold, and right under it is a little tiny, tiny thing, which looks like a little tiny package. And you click on the arrow by it, and it gives you all sorts of things that you can do to the borders of cells. You can have a dark border, you can have a regular border, you can have all borders, you could have only the left border, only the right border, that sort of thing. And I always pick for normal spreadsheet all borders, and it looks like a little box with a ribbon across it. And then you let go, and they all have nice borders around them. I find that when I print a spreadsheet, that helps me to see what's organized with what, so that I don't get things crooked in my mind. Then another thing to do is to wrap long titles. So I encourage people, especially students, to make explicit words for what they want to say. And so titles of columns are sometimes 2-3 words. And if you leave them go, they will run over the next bunch of titles, and that's no good. So it's I think it's best to click on the one that's too long, and you go up high in the menu bar, and to the right of the word Home, there's a thing about font size, 11, 12, 14, whatever. And to the right of that, there's a little thing that says ABC plus. And you click on that, and it takes whatever long title you have and puts it into the box that you have got set for it, and it breaks it as best it can. And that makes it easier to read the whole thing. Another thing that I do, that I encourage people to do, is also to list your resources in the top several rows. So not right at the beginning where you have the name of the whole spreadsheet and perhaps your name and perhaps a date that you last worked on it, like today, but over 4 or 5 columns over, to have things 3 or 4 lines in which you have useful things like useful websites. So I'd put websites there so I don't forget how to get to them. I put papers that I've read there, just a little bit about the name of them and things like that, so that later, a month later, when I go back and use this spreadsheet again, I can remember, oh yes, I remember what I did here. I used this website, and I used that paper, and I used something else, a piece of equipment or whatever. And then on the final, I try to remember on the final right, of all these columns of various data and whatnot, I have a column just marked comments, and that doesn't have anything to the right of it, so things can run off to the right and not be bothered about having to be wrapped. But things that tell you something about mostly why this particular record was poor or really interesting or something like that. Words like that. Okay, so some useful websites that I have found. There's I used for this this endeavor an eclipse map, which a friend sent to me. It's all that sort of stuff, and it's clickable, so you can you have a map of the United States and then this big swath of where the eclipse passed over, the path of totality, and you can move your cursor around and pick any point, just click on it, and it'll tell you at what time the eclipse was most severe there. It'll tell you whether it was total or not there, and it will tell you how much was obscured of the sun. So if it has 100%, then that was total. But many of the sites that I looked at for this project were 80%, 60%, 94.6%. So I wrote those down in my spreadsheet, and thinking that that might have something to do if the midpoint. So I looked for particularly where midpoints between two contacts were. If the midpoint was in totality or the midpoint was not, I wrote down what percentage it was in any case. So that's a useful sort of thing. It is annoying though, and it fills with ads for a while, and then you have to start all over again. But anyway, and then another thing I found interesting is the ICOM US grid square map. And here's where you can get a PDF of it and then print it out. I have a poster size one that I really like. So let's see if I could show you that. It's this one. You all have something like this?
Yes.
Okay, and I just wanted to particularly to tell the people who are going to HamVention, who are now not here, that they should pick up copies of this and bring them home for people, because it's really, really useful. The data that we were looking at from the personal space weather stations, above the green graph with the yellow line in it, they have, whoops, sorry, doesn't matter. Anyway. They do have the grid square listed, and they have latitude, longitude, grid square, other stuff listed. And I find that useful to find them on a map. Okay, so then comes the next part. I've lost it. Oh well. So something to do also in the spreadsheet is to organize your mind or organize your data such that the columns starting on the left contain all stable background information first. So all the things that you know going into this, all the inputs, and then comes the columns for variable information. So for instance, the first couple of columns would be the name of the station, its latitude, its longitude, its grid square, things like that that are not going to change. And then the things that are changeable, like the frequency that they're observing at, most of them are 10 megahertz, it seems. And then the one that I think is, I would like to hear what other people did for this, but I'll tell you what I did in any case. I thought the easiest thing to investigate would be the symmetry of the Doppler shift. So it's the S-shaped curve that goes down, goes up, and then straightens out. I tried several different ways of making that either alphabetical or numerical. I finally ended up with numerical. I like numerical stuff. So what I did is I looked at, as the curve went down, made a downwards triangle, then went up, made an upwards triangle. I looked at it and tried to judge, just made a eyeball judgment, no measurements, eyeball judgment of whether those two triangles were the same. If they were the same, I said, that's very symmetric. And I gave it 100% for being symmetric, or 1.00. And then if sometimes one of them was smaller than the other, I judged how much smaller. So some of them got a symmetry estimate of only 60%, because one was 60% the size of the other one. So I made an estimate like that. We're going to talk later about what other people did for that. Then one of the other things I did.
Hey, Mary Lou.
Yes.
So if I understand what you're saying right, on that S, or on that where it changes, and when you're talking about the triangle, you can almost say that the line going where it's going up, you could almost call that like the y-axis, and the straight line the x-axis, and then connect between the top point and where it comes back, and make that like the hypotenuse. Is that what you were kind of saying?
Yeah. So, and there, it was confusing to me, because at first I started to do it. Did it go down as much as it went up? Was the height symmetrical from zero up to the zero down? And then I thought, well, that's not quite right, because some of them are the same that way, but one's skinny and one's fat. So it's kind of symmetric this way, but not so symmetric that way. So I downgraded its estimate. But probably we're eventually going to have to find something numerical to judge how symmetric, what does symmetry really mean? And in the NSF grant proposal that Nathaniel wrote, he never was specific. He just said, well, is it symmetric going into the eclipse and coming out of the eclipse? And so it's up to us or somebody to finally come up with some estimate of what symmetry means. And I think, I don't know by Hamvention, but I think by the time this comes out as a professional paper, it's got to be numeric. So maybe it's the area of the two triangles. Or...
Yeah, there's as you say, there's a pile of things, and you know the few that I looked at, it was the same. I had the same conundrum. It's just, well, you know, like the actual, you know, the how do you judge the starting point where it sort of starts to fall away from you know, sort of let's say I guess the, you know, the starting point, you know, where the frequency starts to go down, and then you have to judge, well, it's fairly easy to say where it crosses that axis. And then you have to say, well, so that's one number right there. The numbers you're talking about, plus or minus at the peaks. Yeah, you're quite right. There's going to have to be a definition of what exactly we're looking at, because you could have the same area, but it still wouldn't describe it properly.
Right. So Nick, do you have any particular idea which one would be best to start with or anything?
I don't, because I'm not the scientist. You know, like I mean, I was doing something similar with the medium wave stuff, but I was using amplitude rather than signal amplitude rather than frequency shift. And you know, I essentially, yeah, it was mostly how quickly it came away from you know, like the starting point, and up to the maximum, and then how quickly, relatively speaking, it returned back to, you know, the same amplitude. I'm still floundering. You know, and part of that is, you know, like, what are we talking about here? We're talking about frequency at this point. We're talking about Doppler shifts, but there's also amplitude shifts too. You know, like it's we have to be sort of really define what we're meaning by symmetry, and maybe in floundering we can say, okay, well, now we've got some questions. What do you mean? You know, like rather than us saying this is what we mean, because there's no point in us doing, you know, like making a definition and then being told, well, that doesn't tell us anything.
So I have a
Mary
question
Lou,
for Kuldeep. What do you think would be a good estimate of symmetry in this case?
I first of all, I thought maybe seeing the maximum and minimums will give, and it will also have to come somehow in what time interval it came. So say in a minute or in 3 minutes, the same kind of 1 Hz change happened. That will tell us something about the layer movement, or but then I also equally agree on the amplitude part, because amplitudes will somehow tell us about the absorption. So they both are important, but in two different terms. So amplitude will, I believe, will tell us something about the D region thing, and the shift in the hertz will tell us something about the layer movement. So we should definitely go for the number plus and minus max, how much it went, was it symmetric or not? And if we can somehow incorporate the shape can come as a second thing. That's what I think at present. So numbers, max, min, first hertz, second the shape of it.
What did you say with the second one? Say again.
Second one is the shape. S shape, that S shape is symmetric visually or not, that can come later, but numbers should come first. Say
Okay.
1 Hertz plus 1 Hertz minus, that I think should come first. Or at least we should note it down when we are seeing when we are judging visually how symmetric or asymmetric the S shape. This is also note down the number of plus minus Hertz.
Good. Okay. Thank you. So
so
I
Mary-
think that will help me in going forward now. I will write down two numbers for symmetry. One is the ratio of
Magnitude.
minus plus in the hertz,
Mm-hmm.
right? So I will do a kind of an estimate by eye. Later, I would actually take a ruler and measure it. But so if they were both the same, then I would say that was 1.0 symmetric in hertz. And then I would do another one to look at the timing. So relative to the crossing time. So there's generally, I saw there was a short crossing, a short time where it went down and crossed, and then a longer time when it went from cross to back to the line. So maybe the ratio of those two would be a second number. And then, as you said, the graphs come in pairs. There's the green one with the yellow wiggly line, and then there's a white one with a blue wiggly line. And the blue wiggly line is amplitude. And so for not all, in fact, only maybe half of the records that I looked at, did the amplitude at the eclipse do anything. Mostly it was just down at 0, and there was like nothing there. But if there is a something, we should write that down as well. So we'd
Okay.
have A, B, and C.
Yeah,
so-
that will be a good way.
Yeah.
Mary Lou
Sorry.
and
Go ahead.
Kuldeep. So I when I was thinking about this and learning about this scientific method and all of this, one thing I was wondering is, wouldn't we want to start defining or giving a name rather than saying the point that does this or this point that goes over here? Wouldn't we want to try to have some kind of, and again, this is just me as I was trying to look at this and figure it out, because I found myself like when my wife was asking, what are you doing? And I'm like, well, this is called an S curve. And she was like, I don't see an S. And I'm like, I have no idea. I was just told it's an S curve. And then I said, well, see this point here. She goes, what point? Well, this thing here kind of goes down and then it kind of goes up. And well, what's that line called? I have no idea. Mary Lou didn't tell me. She just said to take a look at symmetry. So I don't know. I'm just wondering if we, along with defining symmetry, if we want to start defining giving a name to some of these different lines and points and things like that.
Good,
All right,
good
I'll go
idea. Yes, and
I'll
you
go-
just realize it's not an S curve until you turn your head and look at it this way, then it's an S.
Well, it's a suggestion to let the machine do the work. How about taking the absolute value and just raise that bottom line up above, and then you can have one superimposed over the other, and symmetry should be very easy to see.
That's a great idea. Could you come up with a little example with some pictures or something for next week and show us how you would make that operational? Yeah, the part of the problem is we have an undefined problem or a poorly defined problem. And as Ron said, we need to define the words and we need to define the operations to do as well. So Dennis, see what you could do for next time. Anyway.
Okay, Mary Lou, one other thing,
Yeah.
you know, about the numbers. You have a slope going from, you know, like the starting frequency down to, you know, like the minimum frequency, and you have another slope going up to the crossover, and possibly that's the same slope that goes up to the maximum frequency, and then you have another slope as it declines again, and it's like going back to your, you know, your two triangles, your inverted
Right.
triangle.
Right.
And those are definitely numbers, you know, like that you could define quite easily if you had the numbers there. I mean, what we have is pictures, you know.
Right.
So, you know, like what we really need is, you know, like what I would love to have while I was looking at it, say, oh, I hover my mouse over here, and what's the number? Well, there isn't, of course, you know, but many programs will allow you to do that, you know. You could, but that would be also a way of defining symmetry. So now you have essentially three items, you know, like you have the you know, like the time it takes, the amplitude, the different amplitudes, and the slopes that are associated with getting to those amplitudes.
Right, right. So you've brought up a really good question and deeper than you think. So, and I don't know how to make this operational yet, but I have to talk to Nathaniel sometime about this. So, and that is when you're on the website for the Personal Space Weather Station and you've clicked on some blue link that takes you to so-and-so's observations on 04/08/2024, there's two buttons that you can push. One button is download plots, right? And that's the one I've encouraged everybody to use, and that's what I've been using as well. The one above it is download observations. And that's where you get the numbers. And that's where you could actually do the numerical work. However, these things are huge. So when you
yeah,
have you tried downloading one of them once?
no, they're unfortunately they're digital RF files, so
Yeah.
you have to process them before you can get anything out of them, which is, you know,
Right.
where the graphs came from.
So they're not only huge, but they're also in some weird form that makes it impossible for us to deal with. So I'm going to ask Nathaniel about that, and can we can we get some simple routine where you just say, please decode this one here and give me numbers in the middle part of it, or give a range of numbers rather than the whole blessed thing, because it goes all day. So we're going to ask Nathaniel about that, because there are students, I don't know if Mackenzie is one of them, but people who can do this in Python, setting limits to where the part that you want, but not the whole of the thing, because it's too big. But that's our next step. So I thought first we'd do the visual stuff, and then get to the real numerical stuff. We shall see about that. Okay, so let's see what else we got. So one of the other things to do. So
Can I
yeah.
ask something? So
Yeah, sure.
when I went to that website, I chose the particular day. It gives me two files, two images, two pictures. So and one of them has the subscript of 6, 9, and the other one has 156. But they look similar to me. Is there a difference, or what are these two? I don't know.
So the way I've been, so Kuldeep, the way I've been saying them is that the first graph that I see is green and it has a yellow line across it. Is that one you see?
Yes.
Yes, and then the second one, so that's Doppler shift, that's in the frequency domain.
Mhm.
And then the second one is a white graph with a blue line running across it,
Yes,
and that's amplitude.
yeah,
Yeah,
Yeah.
so that will be useful someday, but that's the one that I find in most of these goes to 0 for most of the second half of the day, and where it should have an amplitude. We're just interested in the little piece that's at the eclipse itself, where it goes doop to doop, kind of like an S. And at that point in many of them, it's just 0. There's nothing to be read for that blue line,
yeah.
which I find unfortunate. Yes, these are the two graphs that we are looking at, mostly, almost entirely the first one, the green one with the yellow line running
Mhm.
across it. Okay.
Will you, will
The
you
Dop-
please,
the Doppler graph.
will you please define what you mean when you're saying amplitude? The amplitude, I'm sorry that I don't know this, but the amplitude of what when you say the amplitude?
I don't
Just
know,
the
but it-
graph,
the
Well,
y-axis,
signal
the
strength.
y-axis is labeled amplitude.
Yeah, but
Right.
it's signal strength. You know,
Okay.
yeah, you know, that it's your S meter.
Thank you. That helps a lot because that's not what I
Okay.
thought. The which amplitude they were talking about.
There you
Sorry, guys. I hate to keep confusing things, but I really want to understand this.
No, you're
this is
clarifying it. You're clarifying it.
go. You're doing a
Believe me.
great job.
This is a big deal to me to be able to participate in this and learn something different than medicine. And so I just have a lot of questions. And I'll tell you right now, I appreciate people's patience with me and helping me learn. So I'll go back to my corner, but thanks.
No, don't go
Good
back to the corner, because you're very good at pointing out where we need to clarify stuff. And thank you, Nick. I didn't really know what amplitude meant, but it just, that's what it says on the y-axis of the blue line. So it's signal strength. It's how loud the radio is speaking to you, right? Something like that. Okay, so the second thing here on this one, I took a screenshot of the United States map from the start of the PSWS site, and it has little markers of where people are. So I printed it out and I write stuff all over it. So it's this one, and it turns out that if you have it up and it's active, you can click on one of these little markers and find out the name of the station, which that has been very helpful to me. And I just write it on this piece of paper here. So one of the things that I have done in this sort of thing is to say, well, there are too many of these for me to do, certainly the first week. Which one shall I choose? So I chose at first one on the East Coast, one on the West Coast, and one in Florida and one up high. Then I really want to do a lot more of them. And of course, I chose Nathaniel's one as well. That's in Pennsylvania. But then I thought, if I look at this picture of this map, and I draw on it by hand where the eclipse path was, went from Texas up through Maine, gentle curve there. Then I thought, well, what these people are listening to are the time signals. So out in Colorado, there's the WWV one, sort of above the word Colo. And then there's the one in Canada, CHU, which is sort of just above the word Ottawa. So I put markers there. And then what I thought is, it would be most interesting to me to have a person on the ground listening to one of these time signals and have the line from them to the time signal go past the eclipse totality. So then I stopped looking at the West Coast altogether, because they don't go past anything. They're just all out there by themselves. And I also disregarded the people in Oklahoma and Arkansas and places like that, and only looked at the ones on the East Coast and the lower East Coast, where they could go on a line to a time stamp place or this way and go past where the eclipse was. So at any rate, so I do encourage people, print out the map and write all over it. So then let's see whatever else. Then the next thing is, you should add columns as you think of them. And my spreadsheet has gotten very wide toward the right. I keep thinking of things and throwing in another column. So one of the things I have is, I look at this picture of the map and I figure where the midpoint is between the person and the time signal place, WWV mainly, and I judge where the center is, and I put what state it's in. Well, it's in Ohio. No, it's in Arkansas. No, it's in wherever. And then I look in the eclipse clickable map, and I look at where the midpoint is, and it tells me how obscured it is, and it gives a real percentage number there. So that's a new column on mine too. How obscured is the midpoint? Is it at the 100% level? So it's in totality, very few of those, but there are other ones that are like 90%, and that may come out to be an interesting thing. And then another thing that is interesting to me is the direction from the time signal transmitter to the midpoint. Because if you look at WWV, most of the things are, well, I'm looking at are eastward of that, some of them southeastward, some of them northeastward, but mostly eastward. But then if you look at the things from CHU, most everything is southward, or a little southwest, or a little southeast. So I'm going to eventually divide the ones that are all eastward from the ones that are all southward. And that, so far, that has not done anything for me, but I think it might be interesting. So does anybody else have other things that they have added as columns?
Mary Lou, were you, like, were you putting this up on the screen? Because I still see strategy, like.
Yep, nope, it's not up there yet. It's just.
Okay, all right.
words.
So, just, like the hand waving would have been really nice to have actually seen a map, but I guess there's only so much you can do to prepare for something like this. But I do understand what you're talking about.
Yeah, I should have.
Business about, like direction, distance, relative to, where the eclipse is and so forth. There's a lot of variables here.
Right. So let's go on quickly because we're running out of time here. Then if you fill in data in the initial columns and more columns and have some sort of symmetry estimate as well, then you want to sort the rows in order. So the first easy thing to do is just sort them by your main output variable, which is your symmetry estimate. I only have one at the moment. Now I'm going to have 3 or 4 of them, I guess. So the way you do that is you highlight all the rows, the data, rows and columns all the way down without the titles. And then you look at the top menu bar and there's data, and then you sort, and it asks you, how do you want to sort them? You say by column, whatever, column Q, then push to do that. Then if you have them all arranged in order, then you could look at all the other variables kind of at once and see if any of them strike you as being as useful, as they trend in the same way, or in fact the opposite way. Then you guess a hypothesis, and then you should write the hypothesis down on the spreadsheet in the upper right. So I have written down several things. Find them where they are right now. Anyway, I had several things written down. Any rate, so then let's see whatever else I had to tell you. This is how to make a graph. I don't know if, how many of you know how to make a graph in Excel, but this is the way you can do this, and you will be able to see that. So mainly you have to choose only 2 variables for a graph. You highlight the first variable's column all the way down the end of the numbers without the title. You hold down the control, which on my computer, I have a PC. It's in the lower left corner of the keyboard, CTRL, and you hold that down while you then highlight the next column of variables, and then you let go. And then you get to actually make a plot, and you go to the top menu bar and it says insert. And then I always pick recommended chart. So you have all of them listed there. You could click on the one you want right away if you know. And it gives you choices, and then you double click on the one you want and it puts it in the spreadsheet. And then you have to move it over so it's not covering up stuff. You have to give it a title. It's good to give it a title. It says title. You click on title and then you type your words you want, and it just puts them there. The one that my students always forgot to do was to give the axes titles. So to do this, you click on the white space near the title, then little things appear beside the graph, you look for the plus sign, which is usually the top one, just appears right outside the plot. You click on it, and then it gives you all sorts of plus things you can do. One is access titles, and you click on that, and then you go and type those. One of the things that is powerful, so I just want to say this quickly, and you go back and try it yourself, is to fit a straight line through a cloud of scattered points. Again, you click on the white space near the title, and it brings up the little plus sign. You click on the plus sign, and it gives you all sorts of stuff. And down at the bottom of that, many possibilities, is trend line. And then you click on the little caret things that go to the right, which gets you more options. And down at the bottom of that, you get display the equation on the chart and display the R-squared value on the chart. I think these are very valuable things to have. And the R-squared value tells you how related the two variables are. If they all fall on a straight line, all the points in a straight line, you get 100%, you get a 1. If you get 0.9, 90% on the straight line, that's wonderful. That's really great. When I did it with some of the variables from this particular project, I got 12%, which is lousy. So they didn't relate at all. Anyway, okay. Again, I chose mostly East Coast stations, so they would pass through the path of totality while listening to either WWV or to CHU. I have not found anything compelling yet. I've only done 24 observations. So the ones that I wrote down and then put an X by on my spreadsheet are, I thought the number of modes, which I counted up as the little small yellow lines on the eclipse S curve. Some of them had 1, some had 2, some of them had 3 or 4 little squiggly yellow lines. And I thought that would be correlated with the distance between the transmitter and the receiver. In that, if you're really close by, you can only have one mode. But it turns out all these people are so far away from the timestamps that they could have 3 or 4 modes and it'd still be fine distance to do that. So that turned out to have no correlation at all. Then I thought my value of symmetry might have something to do with the obscuration of the midpoint, in that if it were in totality, it would be cleaner, and if it were outside of totality, there'd be more smush. That also did not turn out to be useful at all. They were just a big smush of points. Nothing correlates with anything. There was a small anti-correlation between the symmetry and distance, in that the further distance you were from the time station, the less symmetric the S-curve was, but that was only a small amount, so I don't know about anything. For next week, we want to examine more observations, see any correlations. I cannot attend, so you should have to help Gary do stuff. At any rate, let me show something else. Okay. So here's my spreadsheet. And I put graphs off to the right. So here's the best one, which is really miserable. So I named it Eclipse in April, Symmetry versus Distance. My symmetry number, just on the basis of plus and minus Doppler shift, goes from 0 to 100%. There were 2 that I thought were very symmetric. And then across the bottom is the distance in kilometers between the ham radio person and the time signal station. And there is a small anti-correlation, mostly due to 1 point. It's really not very exciting. And the R-squared value in the upper right is 12%. So this is nothing very exciting. So I hope other people can get more interesting stuff. So one of the things I'd like to have you do next week while I'm gone, is to maybe get into groups of 2 or even 3 people and share spreadsheets and make a big spreadsheet for your group that has more of the information on it. So that, because it is very tedious to get information off of this website, I think. Does anybody else think that?
It can take a little
Yes.
time and effort for sure.
It would be
So-
helpful to have the quantitative data.
Yes, it would. But we need somebody to write the the Python or the Polars version to take these particular.
They look like
Right.
HDF files, and they look like there's an HDF reader, but I didn't have time to explore that completely.
Maybe you could do that.
Yeah, but once once you read the files, aren't, as I say, aren't they essentially, ones that you would have to process? You're not going to be able to get the numbers that we're asking for directly from those, can you? Or do I misunderstand what those files are?
I think they're just basically CSV files, big files, but we're not interested in all the smush that goes on for most of the day. We're interested in the period from 18 to 19 hours, UTC, and just give us that chunk, and we could plot that and look at it. We don't need all the other stuff yet, if ever. So I don't know.
Yeah, no,
Certainly the people in Cleveland know how to do that, right? Because that's how they made that really pretty graph that we looked at the first day. The one that had all the different colors. This one, remember this one? I mean, they've got the data. That's what they did. So we have to be able to get that routine and to learn how to use it. Ron will look into that. Ron K.
I don't know about that, but I can at least try to get the data into a format that we can try to look at it, because it's in binary format right now. So
Oh, that's even worse. Why isn't it just real numbers?
apparently the HDF format is designed for like large data files, so it compresses the data into binary format. That's why.
Shucks. We would like real numbers that go from 0 to 9 and not
Yeah, so
ABC.
it would be helpful to get like a description of the data file format, because there's like, it's not just the data files, there's like metadata associated with the files as well. It's not exactly clear what the metadata is. I try to open it up and you can sort of see a few.
This is for which one?
We were talking about the observations, the
The
observational
you're-
data.
You're talking about the digital RF ones?
Yes.
Yes. So
Yeah.
those you really have to use you have to install the MIT Digital RF Toolkit, and you have to use Python and do a lot of processing on that.
Can you teach us how to do that, or give it to us that some student has made it so you just have to input a few numbers like the day, the time period from 18 to 19 UTC, that's all, and spit it out to CSV. Thank you very much.
Unfortunately, that's going to be rather complicated for me to do.
No, you have to
But
find a student to do that.
it's going to be very complicated. So a postdoc might be able to do it.
Cool.
Yeah. Or Rachel Bodeker might be able to do it.
Clearly, she knows how to do it already. She shipped it to us in some the problem is a usable.
So I was
form.
gonna say, if you want something in usable form, the FL Digigrape data is basically what you want. It's in a CSV format that you can easily import into Excel and work with directly there.
How do we get that one?
That's a great question. It should be.
Doesn't seem to be on this particular website, or is it hidden there somewhere?
It is not. It is not on the University of Alabama website. That is correct.
Okay.
And because one of the things, so we're
Do
in
you
a
have
bit of
another website where it is, and we could go to that website and ask, please, can I have CSV?
There is. Gary, do you know if they got that updated to Zenodo?
I haven't seen Christina Collins on the call the last couple of weeks, so I've got no updates.
Christina Collins knows how to do this. Okay.
Yes. Do you have Christina's email, Mary Lou?
I do.
Okay.
Somewhat.
Why don't you email both Christina and Rachel and explain, that you want this group to be doing this sort of analysis, and you were wondering if you could get a hold of the FLDigi data in a way that would be easy for this group to access.
I will do that.
Thank you.
Can I
So
use,
it's been a transition with these data products, because the digital RF data is, as you can see, much more complicated than a normal person can handle. It's not very accessible if you're not good with those tools. Eventually, what I'd like to see happen is I want to see the digital RF data have a tool available that will convert it into the FLDigi style data, and have both of those available through the University of Alabama server. But we're just not there yet. So
That's true. Okay.
Does the MIT site have a description of how the data is written out so that you could try to write such a thing?
oh yeah, there absolutely are tools. So yes, for you, there is a GitHub page with readmes and workflows and things like that.
Okay.
So here, I'll put that in the chat. That is the toolkit you need in order to unlock the data.
can I use my own data?
Are you using a digital RF system or a FLDigi system?
Well, I had a WSPR receiver going in
Mhm.
Ontario for the whole day. And I also had a RF skimmer going for the whole day
Yes.
from Massachusetts.
You can absolutely use your own data. It's just going to be in a different format from what Mary Lou has been showing. But yes, you can
Yes.
definitely use your own data.
Okay.
Cool.
And I guess that's an important point. We have many different formats of data here. And so if Mary Lou is trying to show one particular way of doing this. If you have the skills and the access to some other data that you would like to work with, we strongly encourage you to do that.
So Dennis, for your own data, you have real numbers throughout
Yeah,
the day, right?
I would hope that they're real numbers. I haven't gone to, I did get WSPR data for a project 4 or 5 years ago, but I haven't done it since then. So I'm going to have to learn how to do it again. But I understand the data's all out there.
Yeah.
You just have to be able to find it.
And decode it.
Yes.
I never got my decoder ring. At any rate. So now the real question, I've looked at 3 different correlations and found really nothing. Has anybody found a correlation of anything with symmetry?
I haven't got that far.
Okay. Okay, that's fine. We should continue trying to get
No,
that.
I mean, this is really useful, just what you were describing there, this whole principle of, like you've got all these various sets of numbers, except they're not really numbers. That's what we'd really like to have. And seeing if there's correlations between them.
Right.
It's, because, I mean, what we got is lots and lots of data. What we need to find is what it means.
Well put, Nick. That's perfect. And it would be really good if we could do it in the next week and a half so that Nathaniel could have something to really talk about at Hamvention. My head hurts.
That's okay. You've got a week off, so you can recover.
No,
Right.
but I also think this whole idea that, like there's still this FLDigi data, which is actually really considerably easier to understand. Because it's, if I understand correctly, it is a simple set of numbers where you won't be seeing the modes in that, I don't think.
That's right.
Yeah, you see the one that's strongest. And yeah, that simplifies things a heck of a lot. And it's also something that you can derive numbers from quite easily. You know, it's something that can be understood, you know, without sort of, you know, like having to get into the Fourier transforms and such like.
Yeah. So Nathaniel, when you wrote the
Yeah.
grant and said, we're going to look into symmetry of ingress and egress, did you have anything in your mind at that point, or do you now, about how to operationalize this concept?
I did not have a very strong thought of exactly how I would quantify that.
Okay. Well, we're going to have to hash this out in some
I also
way.
thought about it. I should also say that when I wrote that, you know, I wrote it not looking at the grape data. I wrote that statement looking at the RBN data from the first solar eclipse QSO party. And so I looked at this plot here. And I said, oh, look, this looks a little asymmetric over here. And maybe this does too. And look, maybe that's even delayed a little bit. So I looked at this plot and I said, huh, it looks like there are asymmetries there. One thing you can do, so one asymmetry that means
Do we have these particular plots for the eclipse that just happened?
not yet. That's Kuldeep's job.
Ah, Kuldeep, guess
Yeah,
what you're gonna do?
yeah,
Now
yeah.
you know exactly like this picture. Oh, different
Yeah,
data.
I'm trying to regenerate this kind of plot. And from what we were looking at this day or last couple of days, there itself, I guess we can have the Doppler shift maximum minimum values. Maybe we can see along the track how the Doppler shift itself was changing. There also we can go for one kind of parameter, and this will be accounting for all the links. So this will be all the links together, and that part can be in terms of Doppler shift. So maybe there also we can go into Doppler shift and see along the track whether it was uplifting by the same amount or by different amounts. So
Guess what? It will be all different.
yeah, yeah. Yeah. Yes, I'm trying to regenerate this plot. Yeah.
So you are now working, is it true? You are now working on making this plot like
Yes.
this one.
Yes.
Excellent, excellent. Good job. But many, many more points, right?
And I should say that is not an easy job.
Yes. So, and I thought there would be some real correlation with frequency of radio frequency, but I haven't found that falling out either. So, any rate, more next week or something. So, anybody have any other questions or how to proceed or anything like that? Mackenzie, you're a very organized person, and you can do stuff in an organized fashion. Do you have any suggestions to help the organization of this?
Are you referring to the Excel sheets for people marking
I
the
don't know,
data?
in any sense.
Oh,
Do you have any ideas to help us all out?
I'm gonna think of some and I'm gonna email you if I come up with some, but my plan is to rewatch this video and look at the slides that are posted on the Google groups and try to come up with something.
Okay.
But I also plan on rewatching this video when it's posted to YouTube and see if I can really because I missed the meeting last week because of finals. So I'm still trying to get caught up.
Are your finals finished yet?
Yes, they are.
Hey, Yay!
Yes, so I'm pretty excited about that. So yes, my plan is to rewatch this video, see if I can come up with something, and if I can, I will email you about it. And I know you're going to be gone next week, but I can probably just bring it up to Gary, or if anyone, if
Yeah,
I have any suggestions.
Thank you. Thank you.
Yes, of
I
course.
appreciate your input especially. Okay.
Nathaniel, quick
Yes.
question. You were looking for sort of results to show off, but you
Yes.
mentioned SEQP. Are you looking for results from other parts of the
I am,
HamSci
yes.
program? Okay.
Yes. So Nick, if
I'll-
you'd like to send me some results, I'd be happy to include them.
Okay, I'm not sure I can do that, but what time frame are you looking at? When is this going to be?
When is your talk?
My
Yeah.
talk is Friday, May whatever that 16th is it?
Okay.
17th. May 17th.
Okay, I'll see if there's something. I mean, there's just a ton of stuff. It's whether I can sort of make any sense out of it for you.
I think the title of the talk is like first results of the Festival of Eclipse Atmospheric Science or Solar Eclipse QSO Party. So we don't
Okay.
need to necessarily have all of the answers, but we should be able to show some interesting things. It's like, here's a nice survey that, yes, we actually got interesting data and lots of people got on the air.
Yeah, okay.
So anybody finds anything,
That's right.
send it to
So I
Gary.
think
Gary will.
Jonathan said he would give me a few slides. Hopefully we can get some slides from Steve Serwin's project.
Yeah, no, I can certainly give you lots of colorful things.
Wonderful.
It's just, with hopefully a little bit of an explanation about
Nick, are
what
you
is
going to
on.
be at Hamvention?
No.
Okay.
No, I'm so afraid not.
That sounds great though. Thank you.
Nick used up his one trip to Ohio for 2024 already, right?
Yeah, right. Okay, I'm going to have to bail out, unfortunately. This has been really interesting, Mary Lou. Thank you very much.
See what we can do for next week.
All right, one quick advertisement. Anybody who's actually going to Hamvention, we're going to be looking for speakers to do what are called booth talks, where we meet in the same room as the ARISS program and Youth on the Air. And we share an area in that room. We've got a big TV, and we do short talks, like 15 minutes or so at the most, on any of our subjects that we cover in HamSci. So a couple of you I'm going to reach out to. I've got some ideas, but if somebody else would like to volunteer, please let me know, and we'll see if we can put you on the schedule. We've got 3 or 4 slots easily on Friday and Saturday of Hamvention week. So.
By the way, I don't know if anyone mentioned it, but the KP index is around 7 right now.
Ooh.
There might be some aurora tonight. There's certainly a lot going on up there.
Look to the north. All right, then. Is there anything else? Do you want to call it quits? Because I like Mackenzie, I've got to watch today's video again myself and catch up on my assignments. But I've been doing a little bit of analysis. I picked a couple of stations and I've started creating some data. So I've got I think 16 data points so far. So I'm going to keep going this week. I hope. Hope all else do too.
Right. Something I was thinking you might do, Gary, I was hoping to getting to today, but we didn't, is to somehow whack up the stations into chunks that people should do. Okay, so you're going to do the first page for sure, and then whatever else you like. And you're going to do the second page and whatever else you may like, that sort of thing. So we get them all done. I've been doing the East Coast, which is all different pages. So I don't know, but
with the 2 I looked at, we're using the RX 888 data because that way you get 6 or 7 frequencies off of each observation. That made it really nice.
yes, that's I did a couple of those too, and then
Okay.
Yeah. Anyway, I gotta go. See you guys.
Thanks, Mary Lou.
All right, everyone.
you.
Thanks for attending. Hope you all found it useful. I'm sure it was very interesting. I can't wait to go back and watch it myself. So 73, and we'll see most of you next Thursday afternoon, I hope. Not sooner.
73.
73 all.
Thank you.